We'll talk a little bit about blueprint reading now. If other people show up, they'll just come in. I'm going to eventually try to upload this again. I've got it streamlined now, so I think I'm doing it right. I blew a couple of them. That milling, tramming, and milling one, not so good. The lathe one, no audio. Okay, I'm going to do it again. But today's video, I did 4 of them today, so they're all good. So far, so good. Anyway, blueprint reading. Now, as you're now in the process of getting your subscription squared away. I hope you've been going into the Blackboard shell. So let's take a look at the class. Blueprint reading. And I'm going to go over some of the real basic concepts of that we're going to be dealing with. You know, a lot of this course, as I said, I plan to do lectures. So, but the lectures don't replace the reading, all right? They'll complement it, I hope. At least that's what I'm striving for. But, so right away up there, you files. Those are not your tooling you. You can do those right now. They're PDF files. You can just read them up on whatever screen you're accessing. So if you've got a laptop at home, you access this and read it. They're all PDFs. So this here is a PowerPoint. That in your own time. It's going to kind of take you through the stuff that I'm going to talk about today. We're going to get right into it. So what do you know about blueprint reading right now?
The front, the top, the side.
So you've got some kind of relationship, yeah.
Yeah, I know the basic understanding of it.
Robert, have you had a chance to work with some blueprints or, yeah, mechanical ones?
Yeah, mechanical ones.
Okay.
Where to bend and
Okay.
which way to bend it, the part in.
Okay, so you've got like fabrication drawings, brackets and things like that. Okay, great. And then other prismatic parts and whatever. So that's really, there's 2 main skills in blueprint reading, and that's what this class is going to go through. Skill number 1, visualizing. We live in a 3D world, right? Everything has height and width and length, but blueprints are 2-dimensional, just views on paper. So if I go about and describe to you, you know, a component, cut yourself a 1 by 2 inch by 2 inch square. Drill a hole right through the middle of it, 1/2 inch in diameter. I don't even have to make a drawing. I can. And given that information, you might jot down through it. But think about having to do that for a complex thing like an engine of a car, right? You can't describe it. You can't even describe it in what's called an isometric view. So what blueprint is a series of projections of a 3-dimensional object into 2-dimensional space. But it's also a kind of a language. So blueprints, mechanical blueprints, are a language that is meant to be something you can interpret without words, without needing to know English necessarily. Just think about it. We're a global economy, global manufacturing. I want to be able to take a part that I design and make a mechanical drawing of and be able to send it to California and have them understand it. Be able to send it to South America, have them be able to understand it. So blueprint reading is like the language of industry and manufacturing because it's recognized worldwide, and it's a graphic language. It's not words. You'll see all newer blueprints generally use symbols these days. They don't use a lot of descriptive stuff. Like what we worked with today in semi-precision was a component, was just a very simple block with a hole in it, and we used the words diameter, drill through. Okay, new blueprints and these sort of standard ways don't do that anymore. They'll have symbols that show all the way through and diameter symbol and all that. So many of the drawings we work with are still kind of old school. Modern standards, which are less language and more symbols. The two main skills of blueprint reading are, as I just said, visualizing the part. Being able to take these series of two-dimensional views and actually form a picture in your mind. Is what I like to call interpretation. Not only do you have a lot of views on there, but you have a lot of information on features of the part. Threaded holes, reamed holes, any number of bolt hole circles. There's all kinds of things. There's finish marks, there's tolerances, there's numerous things that have nothing to do with visualizing, but they have everything to do with the makeup of that. Visualization is the first skill in the first couple of weeks in this class. It's just going to be a lot of different exercises in visualizing.
Other information. There's notations here that say 0.06 by 45 degrees. What the heck is that? There's little balloons here. There's other parts. So there's a whole lot of things going on. And this part here, I were to sketch it up in 3 dimensions, would look kind of like this, right? It's going to be just a block. It's a very simple block with a hole in it. 3 holes actually, sorry. 1, 2, 3. That's all that is. That's how it looks like, right? This is what we call a 3-dimensional view. It shows length and width and height all in one projection, one view. So it's shortened as ISO, better known as isometric. Which means I can see all 3 views. I can see the length, or all 3 dimensions. I can see the width, and I can see the height. All in one projection, one view. Right? We live in 3 dimensions, length, width, and height. This is a view. Isometric means at angles. It's a Greek sort of translation that we've used. But yet, how did I get from this, how did I get to this from there? And then alternately, if I give you 3-dimensional views, how are you going to get it onto a piece of paper like that? What's the trick here? What do you just see? This is what that part actually looks like.
Measurements?
Yeah, there's measurements, exactly. So there's proportions. There's length here. There's width there. So this is 3 inches by 2 inches. And this part is overall 1 inch thick. And Leo, you touched on it just a few minutes ago. You said that relationship. All this is a part that's sitting like that, and it's been rotated over, and, and the alignment, you see that it lines up perfectly. This is now what's called orthographic projection. So we're taking something that was originated as an idea in my mind. Translating three-dimensional ideas into working drawings, or orthographic projections as they're better known. So that's the skill we're developing here, is visualizing it. There's a very specific relationship between what we're calling the top view up there and what I'm calling the front view here. And now this particular slideshow jumps into this, which is also very common. Mean we're going to be getting into. So three or four main need to dialogue blueprint. So we said there's interpretation, interpreting what all this other information that is not related necessarily to the graphics, but these are dimensions, measurements, information on who this part belongs to, who wants it made, who engineered it, who changed it, edited it. Okay. Projection. Textual data means interpreting it, okay? What does 0.06 by 45 mean? We have to interpret that. Chamfer side. Interpreting the data or the information. Up there's a bunch of text. You probably don't see it so well from where you're at. But there's information that there's a threaded hole in the middle. I interpreted the information on the drawing. Textual information, but that's only half the skill. The other half is visualizing. Orthographic, these two dimensions. Isometric are projections. I call them projections or projecting. So there's the visualizing those views and projections. And then there's interpreting the other data that's on the drawing. Once you try to make a picture of it in your mind, you can see it. Now what does all this other data mean? What does it mean on that first hole? It says 0.2745, 0.3750. That happens to be a tolerance specification on the extremely precise hole. So that's that interpretation of that. Okay? So now stepping further, let's not worry about all the writing. Okay, so here, and this is a really great way to think about it. This is a way that I've been doing in this class. So the part sitting inside of this glass box is the isometric view. Is a part. It's just a block, right? It's got a front view, it's got a right side, and it's got a top. So again, this is that drawing we just had up there. This would be the top view right here. And then we have a right side and we have a front. So the right side is blue here, right? And then the front is red. Now what they're saying is visualize a glass box surrounding this part. And if on that glass box I looked at the part and I look at it straight down, what do I see? I only see a square, and in our previous example there were 3 holes in it. If I looked straight down on the top. Or if I had this glass box and I sketched this part on that front pane of glass, and then we unfold this part to reveal the orthographic projections. So here is the sort of thing that you see from the front view, okay? So what we're saying is, imagine this part enclosed in the glass box. Everything you see, if you're looking straight at it, it would be just that square right there. I'll erase this. You can describe to me, what would I see when I looked at it, if I look at it straight from the front? So I'm looking at it right on the front side here. And I sketch the outline of the part on
Just one side.
just the square, right? So I have my first part, and then again there's an imaginary glass box around here, and you sketch the outline of your view, and that's what I would see. And now, if we take it the next step, what would I see if I look at this part through the glass box straight down to the top view? Just like right here, it's like you imagine that you sketch the outline of the top view onto the plane of the glass. The glass folds up, and you'll just see another rectangle, but you'll see 3 holes in it, right? So when we look straight down on this part, and we sketch its outline on the glass box, we're going to see not only the rectangle, but we're going to see 3 holes from this drawing right here. That one, of course, there's no holes in it, so you would just see an empty square. And now, the last one, what happens if we sketched what we saw from the right side? We would unfold the box, and that box would come out right here. I would not see holes in any of these views because I only see the holes looking down in the top, right? Here we just see a blank. We sketched this box, in the glass box we said, okay, there's the front view, and we folded up the top view, and then we folded open the right side view. These are the standard. Now notice the align. Okay, this is the front of that square that they had earlier. Or if you look at mine, this bottom is lined up with that. This part is lined up with that. This edge is lined up with that. This edge is lined up with that. We just pasted these things all over the place and just not really. So this is we're going to spend a fair amount of time on. Because if we now modify my block a little bit, if I modify this block on my sample, let me just take these holes out of here. Let me take the top surface and change it a little bit. Make my block and say it looks like this.
does my front view change? Okay. That's right. You're going to have something that kind of looks like an L shape from the front. So it's going to look like this. Right? Agree? Feel? My top view. There's no holes in this anymore, but what am I going to see in the top view? In fact, I'm going to see the outside. Then there's a corner right here. So we're going to see that. If we're looking down on the top view, here's the green surfaces, right? And I see that from the top view, and I see this from the top view. So that means we have a line right there. Is that the line? One extra line, and the circles are gone. But now what do we see in the right side, Dave? This surface, right? That means we get a line right here. Why did I choose to draw it right here? There it is, right there. There's our line. The outside, bottom to bottom. This is what makes it completely free of language. All graphics. This is recognized globally. I can take it to a small shop in China. Like, yes, yes. I have, of course, to provide the dimensions, but see now, understand. Visualizing that, that's a big part of it. These are easy blocks. When things start getting round and angled edges and corners, it gets more and more complex, more complicated. So let's see where this little slideshow takes us. Okay, there it's now showing that although we have selected top, front, and right side, a box has how many sides? It has 6 different sides, right? So when you think about the last box, we typically and so on. So if I gave you I say, okay, let's do the left side view. What are we going to see in the left side view of this block? It would be projected off to the left here, but what was the key word, Leo? It's just flat surface, right? Right. All I would see is a square. This is hidden from my view in the left side, okay? So here's the part that comes up like that. I only see here. Now in the bottom, I have this, and now I rotate it. My bottom view is going to look the same as the top, but we don't see these things. So here's how the views relate, if you just imagine this thing. Here's my front view. Here's my top. Here's my front. Coming out, that's my right side. Coming out, that's my left side. And there's my bottom. Top, front, and right side. Look at the top here, the right side. All of you, and you always put them in place. Now, Leo, he's kind of got us thinking about, even though we don't see this little step, it's still there, isn't it? So what happens? Called a hidden line. The little dash line right here. So it looks exactly like the right side view, but it's hidden. In the bottom, same thing. That's our next little feature. Here's a hidden line. Top, front, right side, optional. You don't see these used that often. You always see these. Sometimes only 2 are appropriate, but you'll generally see a combination of top, front, and right side for prismatic parts. The round parts will generally only question, does the top view change? No. So we still see a line. Does the front view change? Yes. The front view changes to look like this. Does the right side view change? We got a corner here. It should be lined up, always lined up. So the trick is, if you have a corner in one, you have a line. So you see the difference? These two are the same. See the corner there? That's it. That's all there is. Visualizing the part. Coming from an isometric idea in your mind as an engineer or somebody who's doing the design, and then laying it out in the international recognized way of sometimes they'll just pop it right there. That's kind of common these days. You will see that a lot. Here's a simple drawing that we use from our other classes. So here you see that we have isometric view, and they'll put it in there for. These views are very difficult to draw manually without the computer. Go back in old school prints, they didn't have a CAM system, a CAD system. You had draftspeople. You wouldn't see too many of those because it's just hard to detail. But here we have two views. We have what I'm going to call our front view. We call this the front view. We call this one the right. See the left one? The front. We're looking at it from the left side. We have present the view without hidden lines. You know, that's a choice. Because realistically, these are holes going through the whole part, so we would see hidden lines there. But they wanted those things just pretty much only the visible lines, or they just made a mistake when they projected it onto the two views. So how's that?
Good. A little refresher.
Yeah. And it's getting, you know, the basic is visualizing. And the one thing that will be remaining constant, you know, different companies have different styles, so they'll be drawing things differently, you know, using different kinds of interpretive information. But what you can always count on is you will always have views aligned like this, top, front, and right side. They'll always be aligned just like these. Now they may not provide you with every single view. Like I said, most commonly you just have these three. Sometimes you'll have just these three in round work. So, but they'll always be lined up appropriately. They'll always be, you know, length. So now, going from memory, you how is surface again,